What's up, guys? It's been a while. It's been a while, baby, since I made another video. But guess what? I gotta make one. Guys, I gotta admit to you, I feel like an absolute N00B. Yes, that's noob. For those of you not familiar with the terminology. I was talking about OSPF a lot, and I learned something, and I'm still learning. So let me just summarize it this way, guys. I had a topology that consisted of approximately 7 switches, and a few of those switches are stacked. You have a stack at each, a couple of switches stacked at each site, and then and then a couple of the sites were independent, just a single switch, independent of a stack. So basically, about 3 switches in the core stack, another site with 2 switches in a stack, or not a stack, in just a trunk configuration, and then the remaining sites, there were 2 more sites that had single switches. They are connected over an L2 VPN, or a metro topology, if you will. That's what the service providers call it, of course. Well, we know there's a lot more magic going on under the hood that we're, like I said in the past, insulated from a lot of times. Anyhow, so it's just a big switch, right? Let's just call it a big broadcast domain. So I went ahead. Okay, so what I learned is that unlike Cisco iOS, hold on, I'm talking in circles. Let me start with what they had originally. Let me flesh out the scenario a bit more. So they currently have all iOS 1841 routers at each site, including the core, and they're running EIGRP over the provider's L2 VPN. So EIGRP over their big flat switch. Each Cisco iOS 1841 has a routed interface configured that participates in OSPF neighborship / adjacency. Untagged, just whatever. It's a routed interface, so I mean, there's no specific VLAN, and it works great. Okay, this client is in the banking industry. That's all I could say about that, due to confidentiality. But okay, so everything was working right. Okay, but now here's the thing. The core site has a /16. Massive subnet, right? Or massive network. Thousands of addresses, right? And the crux of the matter is that they have a bunch of endpoints configured with static IP address and fixed gateways pointing back to that core, that routed interface at the core. So, of course, as it normally goes, some people above my pay grade handed me a bunch of Meraki switches, layer 3 Meraki switches, and say, we don't want to do EIGRP anymore, of course, because Meraki doesn't support it. We're going to do OSPF. So take these 7 switches, emulate their current environment, lab it up, make sure it works with OSPF, and yeah, have a nice day. So I never back down from a challenge. I always accept new jobs. I'm like, great, sure, little buddy. I'm gonna grab the world by its tail and so I took a job. And one thing I learned right away is there is no such thing as a true, well, I shouldn't say there's no such thing as a routed interface, but in Meraki world, it's not a routed interface in the truest sense. It's an SVI. You have to create your VLAN and associate your IP whatever IP you want to use for your gateway, for all the downstream devices, and then you have to take whatever switchboard, because it's a layer 3 switch, and then untag whatever VLAN you want for that SVI. So in my case, let's just say I use VLAN 222. All right, so untag. So in my mind, I'm like, okay, to establish my little OSPF network or adjacency, I will take each site. I'll take one of the Meraki's, and I'll take one of the interfaces and put it in VLAN 222 untagged, and thereby it will be associated with that IP that I want it to, all in the same broadcast domain. So it'll be a /24. So let's give it 192.168.22.x /24. So I did that. I got all of these sites, or all of the switches. I emulated what I see as being the Metro Ethernet by simply taking a flat switch and plugging a single interface off of each switch into that little flat switch, so they'd all be on the same broadcast domain on the /24. And of course, yeah, they could ping each other. Life is great, until I turned up OSPF and I started trying to advertise that /16 to the remote switches. OSPF lost its freaking mind trying to build that SPF tree. Hallelujah! Yeah, OSPF lost its daggone mind because it was a single area. That's right. Now, overlapping subnets don't work great in a single area, is what I've learned. And I read something from Ivan Papanjak, or however you say his last name. You guys know who I'm talking about, Papanjak. I gotta look up how to pronounce his name, or just get a hold of him and ask him. But anyhow, he basically, oh man, he has this intricate write-up on a similar scenario, but in that instance they were using frame relay, so sometimes I get confused and stuff, but whatever, underlay, overlay, however that works, whatever. But conceptually speaking, it still captured the essence of my problem. And the problem defined is that I established my adjacency with all the participating layer 3 switches, but I could not ping the core interface, the core let's call it the core interface, which is the big supernet, the /16. So I could not ping the gateway on the other side. Well, that sucks, because that's where all the production servers live, right? Usually in your core. Oh man, I was stressed out. So I was going back and forth with Meraki, and ultimately, will you believe, the resolution to the issue was simply creating an additional area. Where did I create the area? Some of you are sitting on the edge of your seats, unless you're Rob Riker and some of you other geniuses. Hi, Rob. You already probably know the answer. I created the additional area on the core layer 3 switch where the supernet exists, the /16, and I advertised that /16 interface into OSPF area 1 as opposed to the backbone. As soon as I didn't touch the other sites. I left the other sites as area 0, because remember, all these other little sites are /24s. They didn't have any trouble routing because they had unique subnets. But as soon as I created that additional area and advertised that /16 interface into it, bada boom, bada bing! I could ping across all sites to the core, from the core to the remote sites, and life was great. Guys, like I say, I feel like a noob, but I learned something there. And any of you that can do a follow-up video and tell me why, I mean, I understand, like, I get it, like the way that the SPF tree is built or whatever, it's hierarchical or whatever. It doesn't like overlapping subnets in a single area. unless you got some other magic that I don't know about. But for any of you guys that could give me a straightforward response, please do a follow-up video, because I want to understand this, or just point me to some information where it's not. Sometimes Cisco technical literature, man, their white papers are good, but they don't give you like a down and dirty answer, you know? That's why I like networklessons.com or some of these other places that really just give you the skinny, man. The high level, straightforward answer. That's what I'm looking for. So, you know, I understand, okay, now I'm working with multiple link state databases. So obviously there would be segregation between area 0 and area 1 in regards to their link state databases, which means that the routes are stored differently and referenced differently. Now those obviously would be inner area routes, I imagine, IA routes. Anyhow, somebody please break that down for me, because I'm going crazy. I really want to get a concrete, solid understanding of that. All right, so hit me up and let me know, and I'll be around waiting for your reply. It's me again. And I told you guys that I was going to do something crazy at the end of each one of my videos. But this one I'm not. This one I'm just gonna leave, you know? And maybe next time I'll do it, little buddy. Peace! And good luck on your journey to your CCIE-SP. Obviously, I got some reading to do. Sheesh. See you later. Peace.